In this video, we are going to tackle access and trunk ports. Now, as we've already discussed in the previous video, we went in and we talked about what a VLAN is and how it works and how you're able to place ports into a VLAN and things like that. And then in order for you to access that VLAN, you need to be able to place a port into that VLAN, which is what they call an access port. Now, the thing that you're not going to see until now in this video is we're going to configure trunk ports as well. Now, an access port is one VLAN ID, so it connects down to the end station. So as you and I are going through here, the important part to remember, typically speaking, and we haven't really dove into anything like hardcore enterprise switching yet, but typically speaking, a access port is only going to have one VLAN ID associated to it. This is not always going to be the case, and even inside the service provider, not necessarily in the core, but inside the service provider in general, you're going to have people that work for the service provider, and they're more than likely going to have a phone. So, especially with IP phones now today, you're probably going to have two VLAN IDs associated to the same switch port. One is going to be for data, the other one's going to be for voice. So that's pretty common nowadays. So if you look at an interface and you see two VLAN IDs associated to it, one for voice, one for data, that's completely normal. But I don't think Viral actually supports that configuration. So like in a regular switch, if I was to configure it, you would see that I would have a voice VLAN assigned to an interface as well as the data. What that's going to allow us to do is if we have, as long as it's got a voice VLAN associated to it, then we'll be able to listen for the specific voice traffic coming in on the switch port, and then that's going to be placed inside the voice VLAN for phone-specific communication. Now, typically this is going to be connected to an end station. Now, in a rare occurrence, and I'm going to bring this up in case you guys see it, let me go ahead and break out my pen pad real quick. In a rare occurrence, why is that not working? 1 second, guys. In some circumstances, you'll have like inside of conference rooms in a particular company or whatever the case might be. Like for instance, you'll have a switch, and the switch will be connected to a what they call a patch panel, and the patch panel is going to be the connection between the switch and the wall jack and an inner cube you might have set up. So you're going to run that to the wall, and then you're going to have the what I call a wall wart. Basically, just going to be the where the computer plugs into this guy. Now, if this wall jack here is in a conference room, and you only have one or two drops inside of a conference room, you can typically set this guy as an access port and not enable port security at the interface level. What this is going to do is it's going to allow multiple MAC addresses to be learned on this interface. So instead of just having, you're going to apply one VLAN ID to this interface, but you're going to learn multiple MAC addresses off of it. And the way you'll do that is you might have like a 16 port or a 12 port or an 8 port little switch sitting here. Could be a regular enterprise grade like a Cisco 3560 or a Cisco 2960 switch, or it could be something lower end. It could just be a little hub that you have sitting here, and then you can have a bunch of people plug their computers into this guy here, and then they're good to go. Now, typically speaking, that is one occurrence that you may see. So if you look at an interface on a switch and you see that a bunch of MAC addresses are being learned on an access port, that is probably why that's happening. Now, I've also detected where people have brought in, equipment from home, or they've gone out to, a local electronics store like Fry's or Best Buy or what have you, and they've bought a little switch because they want to bring in, they have a laptop from home they want to bring in, and they don't have enough ports to plug into it with. They've done that, and then I've noticed an increase in, the port goes down because the port security is enabled to where they can't learn more than two MAC addresses, one from the phone, one from the computer, and they're calling up help desk saying, "Hey, my port's down," and we look at it, we're like, "Well, yeah, you learned more MAC addresses than you're supposed to," and then I'm the inquisitive guy. I'll be like, well, why do you have more MAC addresses? So I'm the kind of guy that I'll stroll to the user's desk and I'll be like, hey, how's it going? And they'll be like, good, how are you? And I'll be like, Is that, did we give you that switch? And they'll be like, no. Like, would you kindly unplug it from our network? And I'll be real nice about it. But like, yeah, don't let that happen again. Because there are occurrences where if you plug in, let's say there's two jacks right here. There's two jacks on this wall port. And let's say this user goes, ooh, if I plug both of them, I'll get more connectivity speed. Common misconception. They'll plug this guy here into this switch. Well, guess what you end up having there? You have traffic coming in to the switch, you have traffic going out to the switch. Well, guess what ends up happening? You create a layer 2 loop. Why? Because this guy probably isn't running spanning tree, but this guy up here is. So if he detects that, you're going to have a layer 2 loop, and you could probably have issues. Or this port is going to go down because it detects a BPDU, and well, that's not good either. We'll talk about BPDUs when we get into spanning tree. Basically, a BPDU, if you don't know what it basically is an identifier for the switch. We'll talk about that more later. So if you see a situation like this come up, you know what to look for. That's just some native understanding of how networks work. Now, when it comes down to trunk ports, they're kind of sort of the cool guy in town. Why? Because they allow more than two VLANs to cross between switch interconnected links. So the idea here is if you want to be able to get, if you have, a 3, 4, 5, 6 switch daisy chains together, what'll end up happening is the trunk links, assuming you have more than one VLAN, are going to allow the VLANs to communicate between switches and then be able to communicate with the edge device, which is typically going to be a router or a firewall, and then carry on from there. So how does this work out? Well, let's take a look at that. In a case like this, we have where switch 1 and switch 2 need to talk to each other. And let me make my thing just a touch bigger and change the color. So in a case like this, you'll have where switch 2 and switch 1 need to talk to each other. In the previous video, we put gig 0/1 and gig 0/2 both inside of VLAN 13, right? Now, that's great, but we also noticed that R1 could not ping R3. But that was the expected outcome. Now, we're going to fix that, and what we're going to do is we're going to take gig 1/1 and gig 1/2, and we're going to configure these both as trunk links. They're both going to match, and what that's going to allow us to do on both ends of the connection here is we're going to be able to exchange VLAN information between switch 1 and switch 2. This is going to mean we're going to be able to exchange the VLAN info. We're going to be able to exchange the MAC address table, and we're also going to be able to exchange the spanning tree information. I don't know why my pen's acting up on me, but that's going to be how we go about doing that. So what we're going to do here is I'm going to go ahead and pull Secure CRT up, and what we're going to do from here on out is we're going to get this guy ready to support multiple connections. So here on switch 1, we're going to go to global config, type in our password as Cisco, and we're in. We're going to go to global config. What we're going to do is we're going to type in interface gig 1/1. I'm going to show you guys how to do this on a per interface basis, and then I'm going to show you guys how to use what they call the range command. What the range command will allow you to do is enter multiple ports at the same time with identical configuration. So in this case here, if you're brand new to networking and you're not sure how to do stuff, this is a step-by-step breakdown on how to configure a trunk port. So what I'm going to do is I'm going to type in switch port trunk question mark. I have the encapsulation command, which is going to ask me what encapsulation do I want to use on this port, and I'm going to say .1Q. Okay, I could use ISL on both ends of the link, but ISL is Cisco proprietary, meaning that it cannot support connectivity to an HP switch or a Juniper switch or a Brocade or a 3Com switch. It has to be Cisco box. So if you're going to be dealing with interoperability at all in your environment, and the way that I normally do things is I use .1Q encapsulation regardless because it just makes life easier. I'm going to type that in. I'm also going to type in switch port mode is trunk. Now, let me do this now. I'm going to go to interface 1/2. I'm going to type in switch port mode trunk. Now, what it's doing is it's squawking at me. It says command rejected. An interface whose trunk encapsulation is auto cannot be configured to trunk mode. Now, what does it mean by auto? We type in do show interface gig 1/2 switch port. We are auto because that's the administrative mode. That's why that's happening. Now, on gig 0/1, we configure this guy to be static access because we went to the interface level and we typed in switch port mode access, switch port access VLAN 13. Now, what I'm going to do here is I'm actually going to set the encapsulation. So I'm going to type in switch port trunk encapsulation .1q. Now I can go ahead and if I do this guy again, you're going to see that we're set to dynamic auto still, static access, but you'll see the trunk encapsulation is .1q. It hasn't actually affected anything. If we go back up to the top here, you'll see that the trunking encapsulation is negotiate. So it's going to use dynamic trunking protocol or DTP to do that. So now I'm going to go ahead and I'm going to say switch port mode trunk, and now it'll take it. If we go back to here, you'll see that .1q is this guy, and the operational mode, that's cute, it says it doesn't know. Let's do that again. Now it says trunk. It hadn't had time to figure it out yet. So now it has figured it out, and that's the important part. So now we are trunking encapsulated. Everything looks pretty good from there. So now what I'm going to do is I'm going to type in do show interface trunk, and right now gig 1/1 is good to go. So with that being said, I can go ahead and I can go over to switch 2 now, and I can say on switch 2 show interface trunk. Now you'll notice that we have a couple coming up. Before, this would not have come up. The reason for that is because the other end of the link is now configured as a trunk link. Now, a couple things that are interesting here is the mode is auto, and what we have here is the auto configuration means that DTP is configured. Now, the interesting thing here is we look at switch port 1, or I'm sorry, switch 1, you'll see that the mode is on, which is hard-coded to be a trunk port, and this guy right here is encapsulation 802.1q. You notice on switch 2, it's auto, and it's N-802.1q. Now, let me ask you a question. What do you think the difference is between those two outputs? I'll give you guys a couple of seconds to think about it, and I know you guys can't answer the question, but give it a second to think. The reason why is this guy here is using DTP. It's dynamic auto is its default configuration, so it has not been hard-coded to be configured as a trunk port, as a access port, or anything else. This N means it's negotiation. The other end of the link, so switch 1 on gig 1/1 is configured for 802.1q. Now, the interesting thing about this is if I was to go back to switch 1 and type in, and let me do this the interface range command, I'll type exit out of here, I'll type in interface range is going to be gig 1/1 through 2, and I'll type in the switch port trunk encapsulation is negotiate. A port which is configured to trunk mode cannot be switch port mode is dynamic desirable. There we go. So now if we go down here, we do a do show interface trunk, you'll see now that it's set to desirable and that the negotiation is ISL. The same thing over here will be the same if we do the up arrow. Notice how it says it's auto and its negotiation is ISL. That's the default configuration, because what the switch port is going to do by default is DTP, or dynamic trunking protocol, is going to kick into play, and because these are Cisco switches, they're automatically going to try to negotiate ISL encapsulation. They both negotiated that because that's their encapsulation. Now, we haven't talked about the encapsulation much yet, but the difference between the two is where ISL, it's a 30-byte encapsulation. It encapsulates the entire frame. So you have a 26-byte header and you have a 4-byte trailer. In total, that's going to be in total encapsulation, which adds 30 bytes of header space, where an 802.1q frame tag is much smaller. It's only 4 bytes, and it's injected or shimmed in the layer 2 header. So it doesn't encapsulate, it's just a signaling technique so that the switches know what to do with each other. So as you can see, we have that situation. Now let's go back to switch 1, and instead of saying switch port trunk encapsulation negotiate, we're going to say .1Q. Okay, now we go back over to switch 2, and we hit the up arrow. Now they are negotiation of 802.1Q. Now they're both negotiating 802.1Q because DTP communication was going back and forth, and .1Q was negotiated. Now spanning tree is still trying to kick in to figure out what's going on here, so I wouldn't jump too far ahead. What I'm going to do now is I'm going to say here, I'm going to say switch port mode is trunk. I'm going to do a do show interface trunk on this side. We should have mode is on, which means trunking has been hard coded, and the encapsulation is 802.1Q, hard coded. Go to switch 2, get the once. Now we haven't hard coded this side, so as you can see, nothing's happening. If I come into global config, I type in interface range gig 1/1 through 2, I type in switch port trunk encapsulation is .1Q, and switch port mode is trunk, and do show interface trunk. Now I am on, and I am hard coded .1Q. Now if I type in do show MAC address table for VLAN 13, now I have both MAC addresses. Now how did that happen? Well, I'm now allowing MAC address propagation between the switches. So that's what's happening. So now that I've dynamically learned, and they're dynamically here. They learned it through ARP and things like that. Now that they know the switch, the MAC addresses, I should be able to go to R1. Let's go to R1, and I'm going to do a show IP interface brief. I'm going to ping 10.1.13.3. Do you think it'll work now? I am fairly confident it's going to. Now this first ping that you lost right here, this guy, that is an indication of ARP. Anytime you see a dot and then you see 4 exclamation points, that means that ARP had to happen. If I type in here and I do show ARP, I know that the MAC address of 10.1.13.3 is FA16 3ECF 015C. Okay, that's how I know everything's working. So I have bidirectional communication between these switches. That means R1 sent a echo out to switch 1 forwarded that to switch 2 forwarded that to R3, router 3 did an echo reply, R3 to switch 2 to switch 1, back to R1. And that's how the traffic is being forwarded. So beyond that, that's where you're in good shape. Now, what about the other switches here? Well, what about them? Well, we need to get this situated for the rest of these guys. So how can we do this as quickly as possible, but also be thorough as possible? Well, the quickest way to handle this would be to use Notepad. And if you've never used Notepad, that's okay. At least for this type of deployment. What I'm going to do is I'm going to build a little script for you guys, and you guys can follow along at home. And I'm going to grab Notepad out. I'm going to bring this guy over, and I'm going to show you guys how to script this so that you guys know how to do it. So what I'm going to do, and this is just something that you can, one of the things I find very helpful when I'm learning something new is I configure it manually a few times, and then I try to remember what the syntax is and keep it in a Notepad doc. And I don't save these; I rebuild them every time so that it builds that muscle memory and it basically helps me remember what command, what order, and where I should be applying the syntax. So I'm going to go and type in on global config. I'm going to type in interface range gig 1/1 through 3, and I'm going to then type in gig 2/0, and here I'm going to type in switch port trunk encap.1Q, switch port mode trunk. Okay, now that's going to give my syntax what I need for all the other switches, because they all map up the same ports, because that's how I did it when I set it up. That is going to be how I go about getting the rest of these switches configured. So I'm actually going to have to go to the other switches here and type in, actually I'm not going to do that because I don't want to screw anything up. So I'm going to grab this guy right here. I'm going to go to switch 2, and I'm going to copy and paste this in here. There we go. I'm going to come over here and I'm going to go to switch 3 and do the exact same thing. enable config t, host name is going to be switch 3, and then I'm going to right click and paste this in. There we have that. You can go over to switch 4 and just repeat the process. And voila. So there are all my ports that need to be configured as trunk ports have been configured as trunk ports. Now what that's going to allow me to do now is I'm going to be allowed to come in here and type in do show interface trunk. And then I have the VLANs. Now I've already had some other VLANs that I created and that are operational, but as far as I'm concerned, everything else is working as it needs to be. So now what I can do is I can come over here to switch 1, and I'm not going to do anything beyond that because I have in the next video we're going to talk about the propagation of MAC address information dynamically using VLAN trunking protocol, so you guys at least have an idea of how that works. So right now we are about 80% of the way through our core infrastructure, which means getting the VLANs configured to place ports inside of the VLANs. We have trunking configured so that we can dynamically propagate VLAN information between the switches. And we're going to go ahead in the next video and get VTP configured so that we can see exactly how we can dynamically propagate VLAN information between the switches. And then, of course, trunking will allow the MAC address flooding and things like that. So before I take you any further, let's take a look at the .1Q encapsulation and the ISL encapsulation so we know exactly what that looks like. So as you can see on the screen, we have our ISL header and we have our 802.1Q and 802.1P frame. Now, the way that this works out here, and we're going to make this a little bit bigger so you guys can see, ISL stands for Interswitch Link, and that's what the encapsulation is for. And what you do is you have 26 bytes up front, 3 bits used for the class of service. This is known as quality of service, so that it can prioritize traffic over the other side. And these 3 bits are going to be used. You have 3 bits, so that means you can have. It's going to be was it 4, 2, and 1 is its setup, and then if you do I believe that's depending on which one you have enabled is going to be which way you forward, and I believe COS5 is going to be the top, the biggest one you can send. So that's going to be how you would go about doing that. So, but we're not going to be talking about QoS right now. That's going to be coming up later on. But you have this is the actual encapsulated frame is inside of here, inside the red area. This is the encapsulated frame right here. So this is where everything else gets going. You have the 26-byte header, and you have the 4-byte frequency check sequence. This is going to be the basically error checking and things like that. Now, 802.1Q is a little bit different. Now this is the entire. You have the preamble, you have the start of frame delimiter, you have the destination address of where you're trying to go, you have your address where you're coming from, and you're going to have the tag. This is the actual 4 bytes right here. That is it. Now, inside this 4 bytes, the first part of this guy is the first, I think, 12 bits is going to be dedicated for actual VLAN IDs. And so which means from here is going to be you're going to see up to 4094 is what it's going to be set up for. So you can take that into consideration. So that's how you would go about looking at the tagging. So you also have 3 bits for quality of service, user priority. So obviously, I'm assuming you don't know anything about quality of service, where the lower number is always going to mean a lower priority, and the higher number is always going to mean a higher priority. To where, let's say, for instance, my class of service is going to be COS1. That means that my traffic is going to be like, best effort, anything that doesn't have a higher priority. Where 5 is typically going to be for voice, something like that. Same thing with down here. That's going to be how that comes into play. Now, typically speaking, you're not going to really play with QoS too much, at least at this level. You're going to see it more inside the CCNP, and when we get into things like the core routing and the for the advanced route and for the MPLS sections of core and edge. You'll see that a lot more when we get into those levels, but that's pretty much how you would take a look at the framing. That's going to be pretty much how it works out. So beyond that, that is pretty much everything that exists. In case you're wondering what 802.1p, this is typically sent from the IP phone, and this is going to be the priority bits, and the phone is going to mark its traffic as prioritized because it's going to be voice traffic, assuming that you have a voice VLAN configured, and as long as you have QoS enabled at the interface level. What's going to end up happening is an 802.1p frame can't live outside of an 802.1q trunk. Because technically, it's not an 802.1q frame, because 802.1q is an encapsulation, and what you're doing is you're signaling using the tag. The tag is going to have the VLAN ID in it. So on the switch side of the house, when we take a look at switch 1, here we'll take a look at switch 1 real quick, and we'll log in, do a show, or Cisco, we do a show VLAN brief. You'll see that even though we have VLAN 13 configured, we had to name it on our side. So that's going to help us, from a human readable perspective, help us understand what VLAN 13 is supposed to be for and what its purpose is. Because you can configure the VLAN, and it's actually going to show up as VLAN 0013 or 0022 or 24, etc., depending on how you want to look at it. That's going to be how they're set up. So by you coming in here and naming it, you know it's going to be R1 to R3. So that's going to be the key factor in understanding that piece. So that's pretty much where it sits with encapsulation and stuff like that. What I'm going to go ahead and do real quick is I'm going to bring our topology back up, and we're going to go ahead and we're going to configure. Well, actually, you know what? I'll do that on the next video because we're going to do VTP and we're going to propagate the VLAN information. But I'll need to create VLAN 311, and that'll need to propagate between switch 2 and switch 1, and then 212 and 24 will need to propagate between 24 or switch 3 and switch 4, and go from there.